Hey everyone! Thank you for joining us for another episode of the Build AI Apps with Azure Database for PostgreSQL series. My name is Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our hosts and speakers to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over for our speakers for today. Thanks so much for joining.
Okay, hello everyone. I'm really glad to see you around. And well, today we kickstart this new series about building AI apps and agents with Azure Database for PostgreSQL. And well, things have been evolving, like we have this AI revolution that is affecting every one of us. So we need to build apps that are powered by AI. But we also want tools that are powered by AI or that make our life easier. So we are going to do how we can achieve all of this with Postgres today. So, well, let me introduce, I'm just hosting today, but well, the main speaker today is Narin. So Narin, let me introduce yourself.
Yeah, great to meet the team. Thank you so much for being here. My name is Narin, and I am from the PostgreSQL engineering team. So super excited to be here and really excited to sharing some of the key product innovation we are doing.
Yeah, there is definitely lots of features, a lot of things that Narin is going to show today. So, but before, if in case for somebody is joining this session and maybe that doesn't know how it ended up here or is catching up on the Reactor YouTube channel, you can still join the sessions by going into this URL or taking a look at the QR code so you can catch the following presentations during the next 2 weeks. And since this is the first day, we are going to talk about the full series. We are going to cover many things. The first session today, let's say, is like laying the foundation for the series. So Narin is going to talk about all the features, a little bit about the theory behind the scenes. We are going to see some demos. But next session is going to be more focused on the Visual Studio Code extension for PostgreSQL. That's something we released at Build, and all the powerful things that you can do with agent mode. And it's going to be a pretty interesting session also with someone from the engineering team, who is Rob Emanuel, who is doing this main coder for this thing. And also, in the next session, we are going to talk, and I will be speaking in that session, is about building financial apps with PostgreSQL and AI. The idea there is we're going to have SOWs or bills that we have as PDFs, and we want to get this information out and validate it and create apps with this. This is an interesting subject. And the last session in the series is going to be about building advanced AI agents, and in this case, it's for legal purposes. And both of these two examples, the one I mentioned before for financial apps, and this one will have an associated GitHub repo that you can check out and go into detail. So, without talking more about this, let's go with Narin on the main session today.
Great. Thank you so much. Super excited. Thank you, Ismail, for giving that great introduction. What I'll do is, if you have time, I'll just do a 1 or 2 minute on the VS Code demo also, so that you can see what's coming. It's pretty exciting, for the next session here. So with that, let's just go for a few of those for whom PostgreSQL, or at least Azure PostgreSQL, is new. So just wanted to start with a few foundational elements about the product itself. So Azure Database for PostgreSQL Flexible Server, that's the name of the first-party managed service. So this is a fully managed service from Microsoft, right? So completely managed. So think of it as if you're using SQL or Cosmos DB or anything from Microsoft. It's a full first-party service, support, everything. It's an Azure service, fully supported from Microsoft, which is called Azure Database for PostgreSQL Flexible Server. Not many people know this. PostgreSQL is the preferred choice for developers. And we'll go into some of the reasons for this. But this is what, especially as we think about agentic AI apps, right? We see that PostgreSQL is absolutely rising to the top. Various reasons for its security, enterprise database capabilities, extensibility, many reasons which are driving this. So super excited to be here. And the next session is, from a developer perspective, we are doing a lot of investment, for the developer community, as we think about Azure PostgreSQL from the engineering team. And the VS Code, which extension, which Ismail talked about it, is one piece of the product innovation we are driving. Okay. So this call, and it's a global audience here, so I just wanted everybody to know that Azure PostgreSQL Flexible Server is a completely global managed service. So whether you're in the US or Asia or Europe, is fully covered. So I just wanted to let you know that we have 60 plus regions available, and we are constantly expanding every day. Okay. Although this call is about AI and building agentic apps, I just wanted to know that when customers are building agent apps, right? So one of the core pillars of the agentic AI app or the AI apps you're building is security, right? And the enterprise database capabilities, right? Scaling, performance tuning, disaster recovery. So Azure PostgreSQL, everybody may not know, is the only PostgreSQL which fully supports Entra ID, right? So what that means is if you as a customer or a partner are building a solution with PostgreSQL, you don't need to have a separate security strategy for rest of your workloads and a separate strategy for your AI app, which you're building on PostgreSQL. So it's fully Entra ID integrated. So private endpoints, virtual networks, first-party integration to Defender, GeoDR, performance tuning capabilities, all of those things come out of the box as you think about Azure Managed Service. Some of the largest customers in the world, including UBS, Boeing, SAP, Swiss Re, are running, United Healthcare Group, so, across multiple verticals. Some of the largest companies in the world today have bet on Azure PostgreSQL. So this is an enterprise platform, to support building your AI apps. So let's go in now into AI agents. So before we go into PostgreSQL, what I wanted to start for many of you who are sort of new to this or just getting ramped up. So I wanted to just start with the core pillars as we think about building agentic AI apps. What are the 4 pillars which are key to building any agentic AI apps? So number 1 is flexibility, orchestration, memory. Both short this whole session. Now we'll talk about how PostgreSQL helps and builds on each of these pillars to build your agentic AI app. But let's take a step back. Okay. So when we, Ismail, can you stop typing? We can hear your voice.
Oh, sorry. Excuse me.
So if you think about at a very fundamental level, take a step back, at 100 feet, 100,000 feet level, what do we mean by an agentic architecture? So you can see from the screen. So 2 things about the agent, right? At a very fundamental level. Number 1, it has an LLM which can process user requests and reply. So an agent is connected to an LLM. And the second thing is an agent has tools that it can use to complete the tasks. So think about the LLM for user processing, user request, and the availability of tools which an agent has, right? And those tools can be very different across agents. So in this case, as an example, an agent could, in this case, we are showing that this agent has 4 tools. It has a vector search, SQL queries, which are using the PostgreSQL database. But this agent is also using a calculator as its tool to process some of the user requests and a web search, right? So the power you will see as we go through this session, the power of an agentic AI app is the ability to associate different tools based on the context of what you want the agent to do, and for it to ability without automatically having the context and the ability to pick up the right tool to execute is what makes the agentic AI so powerful as a paradigm. Okay. So I thought it would be useful to talk and compare, right? So till now, if you go back a few months back, right, I wanted to, all of you are probably familiar with the RAG architecture. I thought that would be a useful context so that we can do some comparisons between RAG architecture, which we've all been using, and the new Agentic AI architecture, how they are different, what are some of the advantages of the Agentic AI architecture. So just to summarize, right, if you think about, the RAG architecture, right, it's very straightforward, very simple, but rigid, right? So you have a query, where the customer is entering a text. It could be a chatbot. You have a vector search, so you go and vectorize it. You can use any of the models, LLMs, to do that. And then you provide the prompt and the context to the chat, to the LLM, and you get a response. So in a very simple view, the customer, it's a very vector search where it goes and gets data, that vector index, their vector is stored in PostgreSQL in this case. You get back the vector, you provide it in the prompt, and you get the LLM. Very simple, very straightforward RAG architecture, which we all are very familiar with. Now, let's bring them two together to get more clarity, right? So I sort of put both of them together. So what do we mean by flexibility? Okay, so you can see here that in this case of the right side, agents can switch tasks. So unlike a RAG, which is a very straightforward a vector search, prompt, context, and back to an LLM, you can see that the agent can integrate new tools without needing to be reprogrammed. So it has flexibility based on the context, based on interacting with the LLM, based on the user input to pick the right tool and to provide the context. So you can see that there is much more flexibility in building your AI app with an agent architecture compared to a relatively rigid and more simpler RAG structure. So this is sort of how you can think about from a flexibility perspective. Now let's take the second pillar, orchestration, right? So as you can see here, the top RAG, I just wanted to put it there so that you can do sort of a little bit apples to apples comparison, right? So we talked about it's a straight line, right? User enters an input, you do a vector search, prompt, LLM, and product page. What I mean with in this case, I just wanted to show this example in the context of a retail customer, right? So a retail customer wants to display a product page based on the user input. It takes the context and you get the product page based on the context and the search on the top. That's RAG, right? Straightforward. Now you look at the more powerful, flexible agentic model, right? So in here, in an agentic mode, you can have multiple agents. And all those agents have their own LLMs, which they're connected to. But the key thing is they also can have different tools to do it, right? So you can see the flexibility, multiple tools, multiple APIs, multiple sub-agents. And in this case, for example, if a user inputs for a retail customer, it takes the input and the planning agent decides based on the context and the question, which other agent to call, right? So it may, for example, the planning agent may say, hey, how much are there available? Is there stock available, right? So based on that, it calls the inventory agent, right? And the user doesn't need to do that. The agent can itself, with its LLMs, be able to go and figure it using the logic inside it, right? So that's, you can see how easy it is to make a completely flexible, multi-orchestrated thing, which was not possible in a RAG architecture. So that's sort of an example of you comparing a RAG architecture to a multi-agent architecture from an orchestration perspective. Now let's go to memory, right? Memory plays a very, very important role. Let's take the same example I talked about in the previous slide. I'm a user, I come to a retail website, right? So I log in Narin.ananta, I put in my email address, right? You want the web page to know, I've already given my preferences, right? Hey, I like red color. I like, I like this, my Excel size. I've given sort of my preferences. And it's going to be very important that we don't ask the same question back and back to the user when they log in, right? So the ability of the agents to retain that context, the preferences, and the past interactions is a very critical piece when you think about building an agentic app, right? So this enables personalization, long-term learning, and the user can change their preferences. So there are multiple ways. We talk about the agentic framework, right? So LangGraph, as an example, has a different way they implement memory, right? Mem0, which is a new agentic framework, has a different way of doing it. But again, every agentic framework has a different way of doing it. But I just want to let you know, as you think about building agentic applications and as you think about choosing these agentic frameworks, memory is the third pillar, which is going to be a very key piece as you go and build your application, AI app application. Finally, self-correction, right? This is the last and a very important pillar as you think about your architecture of building your agentic apps, right? So the ability for it to self-correct. So in this case, it's a question coming up, prompt and context, the first agent gives a response, right? And you get a result. But now you have an ability, and in this case, it's a reflect agent. You can, just name that way, where you can check whether the results you are getting maps to what you're expecting to get, right? So that way, you don't have to constantly check. So now that you can train the agent to say, hey, if I'm getting these two codes which are not valid, don't show them again, right? So your ability to self-correct as you build that system over long term is going to be pretty important. So those are sort of the flexibility, the orchestration, memory, and self-correction are sort of the four key pillars as you think about building an agentic app. Okay. So we're not going to go into the details, but we have a lot of agentic frameworks. Semantic kernel, I just put out 3. There are many more. But if you think about the top ones, they are Semantic kernel, LangGraph, and LlamaIndex. What we have seen is, LlamaIndex in many cases is sort of very easy to use. They have inbuilt APIs. LangGraph is at the other extreme. It can be customized at a very granular level, but more complex to use from a user perspective. Semantic kernel is somewhere in the middle. So it depends upon what agentic framework you want to choose. All of these agentic frameworks, multiple agentic products provide the flexibility and sort of cover most of the pieces. It's really up to you. May decide to choose for this customer app. I'm going to go with Semantic kernel or LlamaIndex. So it's really based upon what you prefer, ease of use, or how granular you want to do. Sort of drives the choice for you choosing the agentic framework for you. Okay. The good news is with Azure Database for PostgreSQL, we are fully integrated, irrespective of whether you have first-party connectors to LlamaIndex, to LangGraph, Semantic kernel. So irrespective of whichever agent, whichever agentic framework you pick, with the advantage of using Azure Database for PostgreSQL, it is tightly integrated to all the multiple agentic frameworks. So this is a very important piece on one of the choices, which makes it very simple and scalable as you think about your multiple choices, multiple customer scenarios. Azure PostgreSQL becomes a single choice which applies across multiple agentic frameworks. Okay. Now that we have sort of covered sort of the foundational concepts of what an agentic app is, so let's now look a little bit deeper into PostgreSQL. So for those of you, I know many of you are sort of hearing about this topic for the first time, so I thought this slide would be useful to use. So things to know. There is no license to buy for Azure PostgreSQL. There's nothing called a license for Azure PostgreSQL. So the pricing is for the compute and storage. Okay. PostgreSQL, you can try it yourself. It's an extremely cost-effective solution, right? So you can, I'm not going to go, you can go to the pricing pages of the different solutions and you can compare the cost yourself, but trust me, very, very cost-effective solution. Okay. So if cost is a factor for a customer, if it's one of the top two or three things, you will see that Azure PostgreSQL wins in most of the cases. Very, very cost-effective. There is no separate cost for AI features. So for example, I'm picking graph. Like if some of you might have heard of Neo4j. very expensive. There are some very advanced features. Probably you're using only 20 to 30% of all the features which Neo4j, for example, provides. You have graph capabilities, which are fantastic, already built into Azure PostgreSQL, and we'll go and cover that, right? No cost. There's no separate cost. You just pay for compute storage. This comes with it. Similarly, search, right? Search is built in. Okay, vector indexing with DiskANN, and we'll cover it. It's already built in. There's nothing to buy separately for doing search. Once you use PostgreSQL as your AI intelligent database, search comes with the product, no separate cost. And we'll cover this, native. A lot of people have asked me this question. They send me some of the questions in advance, and they asked me to cover native vector search. So I'll go into some of those details. And again, completely built into the product itself. Okay. So let's go next. So I wanted to put this slide because just so that as we start getting deeper on this, right? So let's cover the foundational pieces. So Azure PostgreSQL is a relational database. It is a vector database, and we'll talk about how to vectorize it, how easy it is to do it. And it is a graph database. So if you are building knowledge graphs, you're building graph applications, all of those can be stored and queried right out of Azure PostgreSQL. You don't need a separate tool set to do that. So that's number one, relational, vector, graph. Okay. One of the big misconceptions when I talk to many have is, hey, Azure PostgreSQL is a relational database. Okay. So the primary thing I can use it is whenever the customer has structured data. That is a big misconception and is wrong. Okay, and we'll cover it, right? So you can build, in fact, most of the PostgreSQL applications I'm working with multiple customers, they all have unstructured data. And that is because PostgreSQL supports JSON-B, right? So the key thing, a second big takeaway I wanted all of you to know is you can build agentic AI apps, graph RAG applications, whether your customer has structured data, unstructured data, or graph data. In fact, I'm working with a oil company based out of Houston, where they have 10 million documents which are unstructured, right? So where they are chunking it, putting into PostgreSQL, they also have structured data. So what PostgreSQL, that's the power of PostgreSQL, Azure PostgreSQL is you can bring into a single place all the structured data, the unstructured data, and the graph data, and use them collectively to build your agentic AI app. So that I just wanted to focus on that because some people think that it's not a suitable place for unstructured data, and that's not true. Okay. So let's get a little bit deeper. Okay. So what's driving Azure PostgreSQL, and we'll touch on some of these core capabilities. What are the core features which are critical in building an AI agent? And I'll go into some of those details in the presentation. First is an extension which is only with Azure PostgreSQL. It make it completely easy and seamless integration with Azure OpenAI, all the other cognitive AI services. And we'll go into a little bit detail into it. The capability to have the tight integration right from the database using the extension. Then we talked about Postgres having vector. It's a vector database with native vector search capabilities built in there. We discussed about unstructured database support with JSON-B. We support graph using the open Edge extension, right? So storing of the data of graph, querying with OpenCipher, all of those things are inbuilt into the database. Now, what I'm not talking about here is completely secure, right? We talked about it earlier, right? I just touched upon it for just a minute. All of this comes you knowing very well that this is an enterprise database, complete scalability, reliability. Some of the largest companies in the world are running Azure Database PostgreSQL. Then you have geospatial data support in there. So we support GIS extension. One of the biggest reasons, you saw the chart of why PostgreSQL is growing and is becoming the number one database for building agentic AI apps. And one of the main reasons, one of the main reasons is extensions, right? So the ability to extend the power of the PostgreSQL database, and GIS is a good example of that. So we support Azure AI extensions. We support about 60 extensions, right? And we continuously keep adding extension. In fact, we are working on supporting DuckDB, to do columnar data source. So lots of extensions are supported, extensive integration, first-party integration. We talked about it, with LangChain, LlamaIndex, all the extensive connection to the OSS frameworks. It really makes this a very powerful platform, for building. And on top of it, extremely, extremely cost-effective. And you will see you can see that I'm doubling down on the cost piece. As you build your POCs and as you scale, the cost piece, as you look into the website and see the cost, it will become very obvious on why I'm stressing on the cost piece. Very, very cost effective for you to build this scalable agentic AI app with all the functionality built into it. Okay. So let's go just one thing for those for whom it is new, right? So we talked about Postgres being a vector database. So I thought I'll just use this one example, right? So the power comes because the vector is stored in the database, the table itself, right? So I put it in the title there. What that means is you have row-level security built in. You don't need to do anything special. It's already built in. So all the security which you assign to the table, it's just a column in a table, right? So the vector is in the same place where your customer data is. So I just provide, if you look at the SQL statement, this is as easy as it is, right? So you say that there's a table called cases. So you say alter table cases, you add a column. It's a vector column. You can see that we call it as a vector data type, and the 1536 corresponds to the dimension, right? So it's OpenAI in this case. So we said, okay, 1536, and you can give any number of dimensions in there. And then you can see, you set the open, and we are using, in this case, we are calling Azure OpenAI, using the AI extension. We talked about that. We are using the text embedding 3 model, right? And this is how simple it is. So you take the name. So in this case, we are passing the name. It's sending it to OpenAI. The model gets vectorized, and it just gets added as a column to the database, which means that you can do vector search, all the row-level security, everything is completely inbuilt into it. What that means is, look at this example. I just put this example, complete vector search, hybrid search enabled. So in this case, you can see that we added the column, the opinion vector. And what I'm doing is the user has given a query, hey, my water is leaking into the apartment. Look at row number 10, right? How do I do that? So you can see, we go and vectorized it. We use the same model. We use the same text embedding. We are using cosine search, and you're comparing it. You can see how easy it is. And this is what makes Azure PostgreSQL extremely powerful. There is a vector database. You can easily vectorize it. You can easily do search. You can easily do hybrid search. All of those capabilities are built into the product. So we talked about Azure AI extension, right? So let me just quickly touch on this. So this is only for Azure PostgreSQL, right? So what Azure AI extension does is, using plain SQL statements, and we saw that as an example above, you can call any of the other Azure services. So you can call OpenAI, you can call language services, you can call model service. One of the questions I get is, hey, Narin, can we only call OpenAI? What I want to do, if I want to use a model from different LLM, can I use that? The answer is yes, you can do that. And the way you do it is by loading your LLM, whichever LLM you want, into the machine learning inference point, and then you call it. So that's the power of Azure PostgreSQL, right? The AI extension. So whether it's OpenAI or any other model or any connectivity, as you think about your app, it's connecting to multiple cognitive services, right? So you can do it, you can call this at the app level, but now, and again, your developers don't need to learn any new language. It's all just SQL. So there's nothing new to learn. So you just use this new extension, and you call all the other cognitive services, to build this holistic AI application. So you can see here.
Narin, sorry, I'm going to interrupt you for a second because there are two interesting questions in the chat. Okay. So the first question is, can the vectors be encrypted from the previous slide?
Let me get back on that. Not directly. I don't think we have the capability, but let me get back on that, Ismail.
Okay, and the second question is, well, can we use these AI features outside of Azure deployment, like the Azure OpenAI extension you showed?
No, we cannot. So this Azure AI extension is specific to Azure.
Okay.
Thank you. Thank you. Thanks, Ismail. And we'll get back on the encryption piece. I don't believe so, but let me see, and we will get back on that reply. Thank you so much. That's a good question. So this is another example of integrating the rich capabilities. You can see, in this case, we are calling the Azure Cognitive Services completely integrated, right? So you don't need to go in at the app level. You can just do it right at the database level using the SQL statements. So now let's go. So now that we have a foundational understanding of PostgreSQL, it can build AI agentic apps with unstructured data, structured data, graph data. We saw how easy it was to create the vectors, the power of Azure AI extension, whether it's OpenAI or any other model. So as we think about AI agents, still there are two core problems as we think about building these agentic AI apps. One is scale. How do you scale? Normally this issue is not big when you're doing a small POC with 100 vectors or 200 vectors. Some of you might see on the screen and say, hey, wow, 1 million vectors is a lot. I don't have many customers using 1 million vectors. But trust me, especially with agentic AI apps, growing across multiple industries, you all know that. Very soon, we are going to have very, very large vectors. And then the capability of how do we scale these millions of vectors is going to become a core topic. So problem number one, how do we scale? Okay. Problem number two is accuracy. Your quality of your GenAI agent responses and vector search accuracy is going to become a very key piece. So now let's dig into how you solve for these two, what capabilities are built into the product across these two. Okay. So DiskANN was built by Microsoft Research. So vector indexing algorithm, okay, and it's a Microsoft research built, and this is what is used by Bing or key products at scale. And you will talk about, so DiskANN is GA and as a vector indexing mechanism within Azure PostgreSQL. So if you think about PostgreSQL, if you look at the indexes which are popular in the market, we have IVFFlat and we have HNSW, right? One is clustering the vectors. The other one is a multi-layered graph. The problem is with IVFFlat, whenever you add new data, you need to go and recluster. So what we're seeing is IVFFlat generally works best if you have large data sets with low dimensionality. But with low dimensionality means it's less accurate. So it reduces your GenAI accuracy. Now, with HNSW, we have multi-layer AI graph, right? So it allows for high dimensionality, and the graph can be updated, but unless it's in the first layer, it works best with smaller data sets, right? So as the data set grows, the search and the memory needed, it's quite a lot of memories needed, which increases the cost significantly. But when you think about an optimal agentic AI application, so what do you do for large data sets, which is what we're going to be seeing in agentic AI apps, with high dimensionality to increase the efficiency of your AI apps? That's where DiskANN comes into the picture. Okay, so very powerful things. So this is built in. Like I said, there's no cost to this. So there's a DiskANN, right? What it does is it does two things very significantly. The first piece is there's a technology called product quantization. So what it does is it does complete compression, which can be from 70+%, varies based on the data set. So as the first step, if you have 1 million vectors, it maintains the accuracy and significantly reduces the cost of the memory needed. And I'll show you some of these memory needed. We saw this here in this slide. In many of the data sets, you need up to 32 times, which we have done benchmarking, of less memory compared to the other HNSW, right? So that's the vector compression. But what it also does in its second step is it takes the full vectors and keeps this on an SSD, right? So for example, if you have 1,000,000 vectors, right, it goes and compresses it. So huge cost savings happen at scale, right? And quantization also improves the speed and the accuracy. And the creation of the index itself, we have built inbuilt memory optimization, happens extremely fast, right? So I just put this slide for comparison. You can see how significantly different the sizes are. So on the top, if you look at the size, we have a schema, cases, so two tables, right? The cases table, one with DiskANN, one with HNSW, right? You can see. So both on the top here, 6276 MB, 6276 MB. But look at what happens when you create the index. Look at the bottom screen, the bottom arrow, right? 150 MB compared with 3688 MB. Very, very significant reduction in the space needed, and very easy to go and create. You literally go in and you enable create DiskANN, and we can create the index, so we can do faster search. The key point I wanted to all of you to let you know is DiskANN is built into PostgreSQL. So this has inbuilt vector search using product quantization, which is driving very, very extremely fast to create the 10x times faster, 4x times lower cost, and 32 times less memory. So as you think about Agent AI, please ensure that you're taking advantage of the native vector search. You don't need to buy the native vector search, is already inbuilt into Azure PostgreSQL. Okay, and the cost advantages increases at larger scale, right? So the larger your vectors grow, the cost proportionality of the cost savings back to the customer, back to you, is going to be significantly higher, right? When you're doing a small POC with 100 vectors, 200 vectors, 1,000 vectors, you will not find much difference, right? You can do the same thing, you can use whatever algorithm you want, but the significant cost savings and the speed starts coming to effect as you move on from your POC into scale, as you move on into production. That's where you're going to see the significant cost savings start coming in out of the DiskANN vector index. Okay. Now, how do we solve problem 2? So we talked about scale, we talked about DiskANN. But how do you ensure the accuracy of the agents? So at Build, we announced something called semantic operators. So why did we do this? Why is this important? What does this do? Okay. So if you think about it, the intelligence, as you all know, is built into the data which you have. Vector search doesn't do a good job of completely capturing the relationship, the semantic relationship that is already in your data, which is what makes your agentic AI app so powerful, right? Because when you're doing it at the vector search level, the relation, the semantic relationship between your data doesn't come up, right? So how do you leverage LLMs from within the database, from within PostgreSQL, to leverage the semantic relationships, become an extremely powerful tool as you build your agentic AI apps. And it allows for faster development of AI apps and agents as you think about it. So if you go to the next step, so we built 4 operators of semantic operators, and we'll go talk about it. One is generate, IsTrue, extract, and rank. Okay, so these are the 4 semantic operators which we have announced at Build. So very quickly, let's go into the details. There's a blog which we will post it as part of the, as we give this deck out. So what basically this is doing is, if you look at AI generate. Think about the power which comes to this, right? You send a prompt to the LLM, you have feedback text, which is a column. The table is customer feedback, right? And you want it summarized. It's very simple, right? You can use any model from AI Foundry. It basically, you basically are telling, in this case, the LLM, hey, go and summarize this feedback for me. And boom, all the function, which is a very manual task of doing it, it performs any arbitrary LLM generation, right? So you can convert to structured data, you can give it a parameter, you can give it a prompt, and you can see how powerful generate can be to use the LLM to be able to perform arbitrary operations, which you can then use into your agentic app. The second one is IsTrue, right? In many agentic apps, you have to make a decision, right? So in this particular case, you get a binary decision. You want to create filter conditions. Hey, I want to only talk to customers, who have chosen this particular color of headphone as their preference. How do you do that, right? So that relationship is stored in the text, right? Let's assume the customer given some feedback where they say, my color is green color. I also like this size. Think about all the work you have to do to go and parse it, take all that unstructured data to go and determine whether it's a binary statement. How do you filter it? So look at this. So in this case, you think about a retail customer, right? They have a table, they have multiple reviews, right? Reviews on headphones, reviews on mirrors, reviews on different products, boom boxes, right? And what you can ask is, you can just say, you can send it to the LLM, hey, the review talks about the product, and you can give the product name, right? And boom, it will tell you immediately. Think about the power of this. Immediately now you can have a filter across all the things, and you exactly know whether the particular review is talking about a specific product or not. So again, this is a retail case, but you can make up your own. Think about all the scenarios where you need a binary filter operation. All of those things just becomes out of the box now using the semantic operator. The other one is extract. This is a very powerful one, and especially in the context of graph. So what is a graph ultimately, right? A graph, to build a graph, you need to know what the entities are, and you need to know what is the relationship between those entities. It can be a very complicated process to do that. But now I'm very happy to announce that using the extract semantic operator, which comes out of the box, right? You can go and pick up these entities, which is now becoming an input to your graph rack, right? So in this case, you type an extract, you say, you pass in text, Alice Smith traveled to Paris. And you tell to the LLM, hey, I want it with these entities: person, location, action. So what you're going to see is the person, it'll return back. The LLM will say, person is Alice Smith, location, Paris, action, traveling. So that's the power. And very quickly, you have the entities, and very easy to start building relationships. And this is a very powerful way to build your graph rack applications. And finally, rank. So this goes back to accuracy, right? So we talked about DiskANN doing it. So this is how you impair search accuracy. So now you're done with DiskANN. You did it. You got your accurate results using DiskANN, vector search. Now, on top of it, you send the results to rank, right? Because it goes to the next level to start doing at the semantic level, right? So right now it also supports cross-encoder models, which are used for semantic ranking, right? So then you can see we use Cohere Rank 3.4 and right now OpenAI GPT 4.0. So think about the power of, you have your ranker combined with DiskANN, and that significantly starts increasing your Gen AI accuracy. So semantic operators, I wanted to make sure everybody in the team knew here. I'll share the deck here, but you can see I put some examples of doing that. So now let's go to graph rack. Simple, right? So the third piece, which is Gen AI accuracy, right? Which is we talked about in graph rack is ultimately it's about an agent. We talked about it in the very beginning. We started with an agent having an LLM and having a tool. In this case, the tool is the graph query. That's one way to think about it. So remember, we have multiple tools, right? And in this case, there's a graph query, and then you go and pick the data graph, which is stored in the PostgreSQL database. So at a very simplistic level, you have the data, you go and construct the graph, and the graph is consumed by the agent. Okay, so the three pieces put together. So on the left side, how you construct a graph, we talked about extract, right? How powerful. So you can use semantic operators to build your graph, or you can use Microsoft Graph Rack, which has its own inbuilt algorithm. So there are two ways. You store the graph. We are supporting Apache Age extension, right? And you can store it as a graph within the database, which is what makes it extremely powerful. And then you have graph consumption and the market. Most of the market lead for graph, as you think about, is doing OpenCipher graph queries, and Apache Age PostgreSQL supports querying using OpenCipher. And again, please remember, no cost. There's no separate cost for graph. As if you go and get Neo4j, we all know how expensive it is. All of these capabilities are inbuilt right into Azure PostgreSQL. So to summarize, you can do a graph database plugin, Apache Age. You can do Cypher. You can do hybrid queries. You can do visualization with graph. And all of those capabilities are built in. So if you take an example here, right, we have Bluetooth, we have things. So you can start building the semantic relationships, the complex semantic relationships using GraphRack, right? And then, as an example, you can use your Cypher query to start building and matching, improving for complex scenarios. You're now starting to do the semantic relationship between not only the product and the review, but now you have the feature, right, which starts giving which feature of this product has good reviews. So that's the graph you can start building, which makes it very powerful as you think about accuracy of your Gen AI agents. I leave it in the deck here. There's a demo here. Let me cover that, but let me first make sure I do a small short demo of the VS Code extension. So let me talk about the VS Code extension in this whole series next time. But just as a teaser, make sure you all have the context. One of the harder things that used to be with PostgreSQL for building AI apps was the IDE to build the apps. So many people of you built pgadmin, clunky, it had some features, but difficult to build the apps. Very, very happy to let all of you know that we launched the new VS Code PostgreSQL extension integrated with GitHub Copilot at build. I didn't say Azure VS Code PostgreSQL, I said VS Code. So what that means is if you're building agentic AI apps with PostgreSQL, so whether they are local, whether they are on AWS PostgreSQL, GCP PostgreSQL, or Azure PostgreSQL, you can now use this VS Code PostgreSQL extension. We have a whole session which is going to go on the details there, and it is integrated with GitHub Copilot SQL. Obviously, there are some very advanced features built in if you're in Azure to go and do that. So that's sort of one very big thing, and we have a whole session coming up on that. Okay, so I want to make sure you all sort of knew about it. So let me go. I don't know, Ismail, you have to tell me whether you can see the volume or the things. Just do a quick short demo. So let me know. Ismail,
Hi, I'm Rob Emanuel. In this video, I'll show you how easy it is to build a database-driven app using Microsoft's PostgreSQL VS Code extension and GitHub Copilot agent mode. Let's jump right in. We see here a Docker Postgres server that I set up with our extension, which we call PGSQL for short. I need a new database for my app, so I simply ask GitHub Copilot agent mode to add it. The agent uses PGSQL tools to connect to the server and create the database, prompting me to confirm modifications. For this demo, I'll select Allow in this session, letting Copilot use the tool without further confirmation in this chat session. I'm building an app focused on brewery data, so I asked Copilot to import data from the Open Brewery DB project, a community-driven open source dataset. Copilot downloads the CSV, creates a table, and loads the data into my database. Every query executed by Copilot gets logged to the PGSQL query history, so I'm able to see exactly what Copilot has run. Next, I ask Copilot to visualize the database schema visualization tool. I noticed this set includes latitude and longitude. I asked for the geometry. The change of ships. Now there is no language. Philadelphia. Let's an app. To the for many reasonable.
Seems the video is cutting the audio. I don't know if it's myself, but
dependencies and writes an endpoint that uses precise SQL queries, leveraging the full context provided by PGSQL. With just a small amount of off-screen work to set up my environment,
I run the API server and test the GeoJSON endpoint, retrieving data for one of the breweries. Now that we have our API, it's time to build the front end. I ask Copilot to create a single-page web app displaying breweries on a map. Copilot generates the front end and modifies the Fast API server accordingly. Copilot chose a popular open-source web mapping framework called Leaflet, which can display the GeoJSON fetched from the API. After restarting the server and opening in my browser, we can see an interactive map of all of the breweries in the dataset. Finally, to expand this simple app into something more impactful, I envision a Wikipedia-style platform that enables more engagement with the dataset. I work with Copilot to modify the database schema to support these more advanced features. Copilot updates my schema and offers to apply the corresponding changes to my codebase. But we'll stop here for now.
Is the other session. I just wanted to give a quick overview of that. So a few minutes. So we still have a few minutes. So let me go. We talked about multi-agents, right? So we talked about this scenario here. So let me go a little bit ahead, right? We talked about, as I was explaining, especially in this year. So think about a retail customer, right? This is the last demo, right? The bottom piece. The customer comes in, makes the user preferences. How do you go and personalize the product page for that scenario? So this is a very common scenario for large retail customers, right? So the demo I'm going to show to you uses multi-agents. You can see how easy it is to use. Uses graph, right? Uses the planning agent and calls multiple agents to go and build that solution. So let's look at the demo, and you can see the power which comes with all the capabilities inbuilt at PostgreSQL, extremely cost effective with all the capabilities built into it. So let's do a quick demo of that, and you can see. Okay.
Hey folks, let me show you today how Postgres can power an agentic application with the Agentic Shop solution next we created for build. First thing, I'll start by searching for headphones with deep bass. So I'm developed by the agent. The agent was able to plan everything that goes into developing this page. First, it could personalize the page, pull inventory from our Postgres database. So let's see what that plan agent does. So basically what it's doing is looking at all my preferences as the user, and it's taking those preferences and telling all the other agents to help me build this agentic page. So since these pages are built dynamically, what we can do is we can ask it to do more. So we can say, hey, show me a summary of reviews on this page. So what it will do is it would do the planning as it did before and now add the summary. So semantic operators to create a review just for this page. So let's do something.
seems we lost Narin. Oh, wow. Okay. So we need to cover for him. Okay, so let me just give me a second. I will share my screen. Second. Back. Just a second. Oop. We should be good to go. Okay, so well, I hope he joins us, but in the meantime, I'm going to do the last part of the session, not his side. I don't know if you're seeing my slides. I think so. Yeah, they are. Okay, so we were almost finishing, so that was the last demo. So what we're going to cover, what Narin showed was what we're going to cover in the next sessions.
Ismail, your slides stopped sharing.
Oh, really? Oh my God. Oh, wait, this is
Thanks,
not
everybody. This is just evidence that we are really, truly live.
This is the real proof that the demo effect can happen on all over the place. So it should be good now, I think.
Yep.
Okay, so I was mentioning that, well, Narin covered most of the fundamentals, let's say, what features do we have, but this is like a sneak peek for the upcoming sessions. So this demo that you saw about Visual Studio Code is what we're going to see in the next session on Thursday. And this agentic kind of application is what we're going to cover in the other two sessions the next week. So, Narin is back. So I was wrapping up, Narin, since we are close to the hour.
Good. I think we are good. Sorry, I don't know what happened, the connection went up, but thank you for wrapping it. But again, thank you so much for this session, Ismail, and we'll give our email addresses, and really enjoyed it. And if any questions, please reach out. My email address is narin@microsoft.com. Thank you, Ismail.
Yeah. Okay, so I'm just going to finish mentioning these things. Well, we have a part of this series. If you want to learn on your own, there is this learning path that is a series of, let's say, lessons that you can follow in this link, the aka.ms/postgres-build AI apps. So you can go ahead and advance on your own or share it with your colleagues, whatever. Also, well, if many people don't know, but you can use Azure Database for PostgreSQL for free. You just go to this link and you can find how to do it. It's part of the free tier of Azure, so you can play with that. And finally, if you want to join, if you want to learn more about the new features that are coming, new functionalities of the database, new examples, all of this will be published in the PostgreSQL blog on Azure also. So there are the 3 links, so don't hesitate. And well, next week, as I mentioned, we're going to continue with the series. Next episode is going to be really like VS Code focused, and you're going to see this agent mode. The demo that you saw, you're going to see it now more in real life practice with Rob Emanuel, who's going to show it. So, well, please let's join us next week. If you still have not registered and you're looking at this video maybe in YouTube or LinkedIn or somewhere else, well, don't hesitate. Or still, you can join the sessions. You can register now, and we can follow along and get the notifications for the series. Finally, I want to do some little ad for the AI Foundry developer community, because we integrate with many Azure AI things. So, well, if you want to learn also more of the AI side of the spectrum, you can join this community. And that's all for today. Thank you for joining us, and see you in 2 days.
Thank you so much. Thank you so much.
Thank you all for joining, and thank you to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. We'll see you at the next one.